हेलो माय फ्रेंड्स, कैसे हो आप लोग। तो हम फ्लूइड मैकेनिक्स का पेपर देख रहे थे जून 2022 का। यस्टरडे वी हैव सॉल्व्ड दिस प्रॉब्लम इन द सिचुएशन गिवन बिलो। अगर आपने इसका सोल्यूशन नहीं देखा है तो यू कैन सर्च इन द प्लेलिस्ट। टुडे वी सॉल्व क्वेश्चन नंबर 1. This question has two part, 1A and B. Okay, so we solve this question today. Okay, so let's start this question. So you can see when the pressure on a given mass of liquid is increased from 3 megapascal to 3.5 megapascal, the density of the liquid increases from 500 kg per meter cube to 501 kg per meter cube. What is average value of bulk modulus of the liquid? Okay. So what is bulk modulus? Bulk modulus is equal to change in pressure to the change in volume divided by initial volume with a minus sign. Okay, but when we write it in the form of density, the expression becomes dp upon d rho by rho. Okay, so just like जैसे हमारे पास यंग्स मॉडुलस ऑफ इलास्टिसिटी होता है स्ट्रेंथ ऑफ मटेरियल के केस में, स्ट्रेंथ ऑफ मटेरियल के केस में आपने पढ़ा होगा, सेम हमारे पास बल्क मॉडुलस होता है इन केस ऑफ फ्लूइड मैकेनिक्स. नाउ what they have given, the pressure is increased from 3 megapascal to 3.5 megapascal. So what is the change in pressure? It is 3.5 minus 3. Okay, now what is change in density? Density is increased from 500 to 501. The change in density is 501 minus 500. And what is initial density? Initial density is 500. Okay, so we solve this and we get bulk modulus is 250 into 10 raised to the power 6. Now what is the unit of this bulk modulus? The unit of bulk modulus is same as the unit of this pressure. Okay, so you can write it here 10 raised to power 6 also, because it is given in megapascal. Okay, so the unit is पास्कल, क्योंकि यहाँ पे डेंसिटी है, यहाँ पे डेंसिटी है, तो केजी पर मीटर क्यूब कैंसिल हो जाएगा. Okay, now you see a similar question has been asked in ESC Mechanical 2020. Okay, so this question is asked previously and this question is asked in 2022. Okay, so now this question is from which unit? It is from unit 1. Okay. Okay, now we try to solve this numerical. Okay, so what is in this? The pressure is increased from 3 megapascal, 3 megapascal to 6 megapascal, and volume is decreased by 0.1%. Okay, now here the volume, the decrement in volume is given. Okay, so here directly they have given dV by V is equal to how much it is given, 0.1%. So we have to divide it by 100. Okay, so now what is bulk modulus? K is equal to, we use this expression, K is equal to what is change in pressure? It is 3 to 6. So change in pressure is 6 minus 3. Okay, into 10 raised to power 6 divide by, हमने 10 raised to power 6 क्यों किया? Because here mega is written. Okay, now the change in volume is 0.1 by 100. Okay, so here is a minus sign present and this volume is decreased by, so this is comes to minus and a minus already present, so this will become positive. Okay, so now you can calculate this thing and you will get the change in the bulk modulus. Okay, so let me solve this. How much it is coming? It is coming to be 3000 into 10 raised to the power 6, 3000 megapascal. Okay, so this is the answer. Okay, so let us now solve the second numerical. A flat plate of 1 meter square area and weight of 100 Newton is sliding down a 60-degree inclined plane. Okay, so here solution I have typed. Okay, so you can read it from here also, and I am solving it right now. So what is the situation? केस कैसा है हमारे पास? ये एक इंक्लाइंड प्लेन है जिसका एंगल ऑफ इंक्लिनेशन कितना दिया हुआ है? 60 डिग्री। एक प्लेट दी हुई है हमें जिसका वेट कितना दिया हुआ है? 100 न्यूटन। नाउ दिस इज स्लाइडिंग अ 60 डिग्री इंक्लाइंड प्लेन, और इस प्लेट और इस प्लेन के बीच में ऑयल प्रेजेंट है। ठीक है, द थिकनेस ऑफ दिस ऑयल इज 1 mm and the viscosity is 1 poise. Okay, the viscosity of this oil is 1 poise. Okay, so 1 poise is equal to 0.1 Newton second per meter square. Okay, so always convert into this unit. So now this vertical component has two forces. One is horizontal and one is vertical. Okay, so these are the two forces. Okay, now this force, ये जो फोर्स होगा ये मोशन में कंट्रीब्यूट नहीं करेगा। मोशन में कौन सा फोर्स कंट्रीब्यूट करेगा? Fv. Okay, so now what is this Fv? This Fv is equal to 100 sine 60. Okay, now what is this? Fh is equal to 100 cos 60. Okay, but we are considering this force only, as this force is only responsible for motion. Okay, so now what is shear stress? Shear stress is force upon area, and force acting is 100 sine 60. And what is the area of the plate is? Area is given 1 meter square, so area is 1. Now since the thickness of the oil is very less, it is 1 mm. Okay, so we assume that the variation is linear. Okay, so you can see the velocity of the oil will be 0 at the stationary boundary and increases linearly to velocity v. Okay, so the variation is here, the velocity is 0 and it increases to this point, which is v, and this variation is linear. Okay, so this variation is linear. So what from Newton's law of viscosity, tau is equal to mu du by dy, where du is the change in velocity. So velocity here, velocity is 0, and let us consider velocity here is v. Okay, so what is change in velocity? V minus 0. What is dy? Dy is thickness in this direction. Okay, thickness in this direction. It is how much? It is 1 mm. Okay, so we write dy is 1 mm. 1 into 10 raised to power minus 3. What is mu? Mu is 0.1. Okay, so we write it 0.1 into v divided by 1 into 10 raised to power minus 3. And what is shear stress? Shear stress is 100 sine 60. Okay, so we solve this and we get v is equal to 100 sine 60 into 1 into 10 raised to power minus 3 divided by 0.1. So it comes out to be 0.866 meter per second. Okay, so hope you got the solution of both the questions. If you like it, you can like my channel and subscribe my channel. Okay, and for further videos keep watching this channel. Okay, thank you.